I think that's it for me. Nicole, if you can hand it over to Josh, I talk about tortillas.
Yeah. I love tortillas, and I don't think that Jessica assigned me this question just because I'm from the Southwest. But it was funny at the reading, while we're switching this over, at the reading, the first day when we were training people on question 6, how to grade it, we had to take a break for lunch, and sure enough, oh, there's my daughter. Sure enough, that first day for lunch, what did we have? Tortillas. It was Mexican food day at the reading that day. So it was really, really good timing. So anyway, this is question 6 about tortilla diameters. Really, it's a question about sampling distributions. And just like Daren was saying that he's excited to use question 2 when he gets to confidence intervals with his students, I am as well. I'm also excited to try question 6 with my students this year when we do the sampling distribution chapter, which is chapter 7 in the 4th and 5th editions. Student performance on the AP exam wasn't very good. I've got my fingers crossed, though, that my students will do better if I give it to them on the sampling distribution test. So we'll see. You could ask me sometime in the spring, and I'll let you know how my students did. A couple quick thoughts about question 6, which is known as the investigative task. For some of you, this is going to be old news, but for some of you that might be teaching the course for the first time, this is very important information. This is from the course description. It says the purpose of the investigative task is not only to evaluate the student's understanding in several content areas, but also to assess his or her ability to integrate statistical ideas and apply them in a new context or a non-routine way. Personally, I love the investigative task, and I commend the original test development committee for coming up with this idea. The idea that students should be able to do more than just mimic homework questions or mimic textbook questions. They really should be able to think statistically, and that's what the investigative task endeavors to assess. So some tips about question 6. Make sure that students have some experience doing these investigative tasks from previous years. Also, make sure students don't save this item for the end of the exam. It does come very last in the exam, but it's worth more than any other question. It's 25% of the free response, which is 50% of the overall. That makes this one question 1/8 of the entire test score. Here's the question. Corn tortillas are made at a large facility that produces 100,000 tortillas per day on each of its 2 production lines. The distribution of the diameters of the tortillas produced on production line A is approximately normal, with a mean of 5.9 inches, and the distribution of the diameters of tortillas produced on production line B is approximately normal, with a mean of 6.1 inches. The figure below shows the distribution of diameters for the 2 production lines. You can see the figure. Question continues. The tortillas produced at the factory are advertised as having a diameter of 6 inches. For the purpose of quality control, a sample of 200 tortillas is selected and the diameters are measured. From the sample of 200 tortillas, the manager of the facility wants to estimate the mean diameter in inches of the 200,000 tortillas produced on a given day. 2 sampling methods have been proposed. Method 1 is to take a random sample of 200 tortillas from the 200,000 tortillas produced on a given day, and then measure the diameter of each selected tortilla. This is your standard simple random sample. Method 2 says, randomly select one of the 2 production lines on a given day. Take a random sample of 200 tortillas from the 100,000 tortillas produced by the selected production line. Measure the diameter of each selected tortilla. Now this is a little bit of a different kind of sampling method, but I can imagine that maybe the facility has the 2 production lines that are on very different ends of the building, and the manager wants to say only go to production line 1 on a certain day and then production line 2 on a different day to be a little bit more efficient in the sampling. So essentially the manager will flip a coin at the beginning of each day. If it's heads, the manager will go to production line 1, part A, pardon me, or if it's tails, we'll go to production line B, and then take the sample of all 200 from that production line. So here we finally get to part A. Now this is a 6-part question, so you'll have to be a little patient as we work through it. Part A, will a sample obtained using method 2 be representative of the population of all tortillas made that day with respect to the diameters of the tortillas? Explain why or why not. So remember, method 2 is where the manager will flip a coin and decide at random to go to either production line A or production line B, but not both. So here's a model solution. And this is just a comment about model solutions generally, the ones that we've been showing you, plus the ones that you'll see in the scoring guidelines on AP Central. These are ideal solutions, the kind of solutions written by a statistician, for example. These are obviously models for our students, but in many cases, students can earn full credit for answers that are not quite as good as the model solution. So if the model solutions seem very intimidating to you and your students, you can let them know that these are sort of dream solutions, and oftentimes they can still earn full credit, still get an essentially correct score with an answer that's not quite as model as this. So here we go. It says, no, a sample obtained using method 2 will not be representative of all tortillas made that day. The sample obtained using method 2 will only represent the tortillas from one production line, not the entire population, because the distribution of the tortilla diameters for the 2 production lines are different. Now, students generally did well on Part A, but there were some common errors. Most students correctly said that the sample would be not representative of all tortillas made that day and gave an adequate justification. For example, by saying that only one line was selected. However, many of these students didn't give a complete justification for why selecting from only one line wouldn't be representative. So for example, it would have been better if students said something like, because the production lines, because the lines produce tortillas with different diameters, selecting from only one line wouldn't produce a representative sample. So the tip is that you should require your students to provide complete explanations that don't require a reader to finish the argument. For example, students who say, well, no, because only one line was selected. Well, why is that a problem? Well, because the 2 lines produce tortillas of different sizes. So you'd like your students to give complete answers. Now, because this was question 6, and because there were 6 parts, we were a little generous with what we accepted for full credit. But should a question like this occur on a different question where there's maybe only 2 or 3 parts, students are going to be held up to this high standard. Here's Part B. The figure below is a histogram of the 200 diameters obtained by using one of the 2 sampling methods described. Considering the shape of the histogram, explain which method, method 1 or method 2, was most likely used to obtain such a sample. So here's the model solution. Method 1 was used to select this sample. The bimodal shape in the histogram of sample data indicates that tortillas were selected from both production lines, which is what would happen using method 1. Method 2 would be likely to produce a unimodal distribution centered at either 5.9 or 6.1. So notice we have a very complete answer here talking about what would be true if we sampled using method 1 and what would not be true if we sampled with method 2. So some common errors and teaching tips. Most students correctly said that the sample did come from method 1. In fact, Part B was probably the best scoring part of all 6 of them. And many gave an adequate justification, for example, by saying the histogram is bimodal. However, many of these students didn't give a complete justification that also referred to the population. For example, it would have been better if students had said something like, because the histogram is bimodal, which is what I would expect when sampling from 2 production lines that have different means. So they often gave us the first half and not the second half of that argument. So the same tip as before, require that students provide complete explanations that don't require a reader to finish the argument. And in the stem of Part B, students were told to consider the shape of the histogram, but some students focused on center or variability instead, or simply restated that method 1 uses tortillas from both lines. So the tip here, do what the question asks. And it seems like a pretty obvious tip, but it's one that you could often repeat with your students and it would be very productive. Do what the question asks. Part C. Which of the two sampling methods, method 1 or method 2, will result in less variability in the diameters of the 200 tortillas in the sample on a given day? So we're talking about on one specific day, which method would provide more variation in the diameters. So the model solution says method 2, remember method 2 is when you select from one line or the other line, but not both. So method 2 would result in less variability in the sample of 200 tortillas on a given day because the sample comes from only one production line. Because the distribution of tortilla diameters are not the same for the two production lines, selecting tortillas from both lines, as in method 1, would result in more variable sample data. So teaching tips. First, the common error. Same error as before, that most students correctly said that method 2 would result in less variability in diameters on a given day, gave an adequate justification, like saying it came from only one production line. However, they didn't give a complete explanation for why selecting from only one line would result in less variability. So it would have been better if students had said something like, because the production lines have different means, using a sample from both production lines would result in more variable diameters. Or the tortilla diameters would have a range of about 0.6 inches when selecting from both lines, but only about 0.4 inches when selecting from one line only. Providing that numerical justification really made the answer easy to understand. So some tips here. Require that students provide complete explanations again, and consider using a numerical justification when appropriate. It's always better to have specifics in an explanation rather than abstract concepts. Makes it easier for students to explain what they're thinking and makes it easier for readers to understand what the student is trying to say. All right, part D. Before I read the stem of this part, I want to make a key point, and that is that so far, parts A, B, and C have all asked about what could happen on one particular day in one particular sample. Parts D, E, and F are going to now talk about sampling distributions. What would happen if you repeated this process day after day after day after day? And students needed to recognize that there was a transition here. And unfortunately, a lot of students didn't have that recognition. So here we go. Part D. Each day, the distribution of the 200,000 tortillas made that day has a mean diameter of 6 inches with a standard deviation of 0.11 inches. For samples of size 200 taken from one day's production, describe the sampling distribution of the sample mean diameter for samples that are obtained using method 1. So whenever students are asked to describe a distribution, they're expected to talk about shape, they're expected to talk about center, and they're expected to talk about variability. And so that's what we were hoping to see in student responses for this part. So here's the model solution. The sampling distribution of the sample mean diameter for method 1 would be approximately normal. That's true because of the central limit theorem. We have a very large sample of size 200 with mean of 6 inches and a standard deviation of 0.11 divided by square root 200, or 0.0078 inches. So common errors. Many students did not describe all three characteristics of the sampling distribution. Some only described the shape, some only described the center, and there weren't really any kids that only described variability, but there was plenty of kids who left one or two of those characteristics out of their answer. Second error, that students were unable to identify the shape of the sampling distribution of the sample mean as approximately normal. Some students just repeated the population shape, saying that it was bimodal, meaning maybe they're thinking about one sample again or remembering that histogram from part B, but most didn't describe the shape at all. And among the students who were able to identify the shape as approximately normal, few were able to give a justification for why the shape is approximately normal. That is, the large sample size allows us to apply the central limit theorem. Now, we didn't require that they include that justification for full credit, but it sure made us feel good about a student when they had that justification included. A very, very common error was that many students did not remember to divide by square root 200 when calculating the standard deviation of the sampling distribution of the sample mean. It's not a surprise to me because my own students make this error when I give them cumulative tests, and I've seen it before on the AP exam. It's a very, very common error. Some of the students just repeated the population standard deviation. Many didn't include the standard deviation at all. And finally, many students used incorrect notation or sloppy language. They said things like x bar equals 6 when they really meant mu sub x bar equals 6. Also, some students stated that the shape is normal instead of approximately normal. Now, even with a really, really large sample size, the sampling distribution of the sample mean is going to be at best approximately normal. So on the AP exam, you want to caution your students from using the phrase normal or believing that a distribution of real data or a sampling distribution is exactly normal. That's never the case. So it's always better to throw that word approximately in front of the word normal when describing data or sampling distributions. So some teaching tips, I've kind of already shared some of those, but give students practice with finding the sampling distribution of a mean when the original population has various non-normal shapes, like in this case the population was bimodal. Remind students of the details of the central limit theorem, and use terminology like the standard deviation of something, and fill in the blank, even when talking about the standard deviation of the original population. I know my students oftentimes get confused at this time of year when we're talking about sampling distributions because there's so many different standard deviations floating out there. Standard deviation of the population, standard deviation of a particular sample, and the standard deviation of the sampling distribution of a sample mean. So by making sure to be very specific when you're describing distributions and standard deviations, your students will be able to keep those ideas separate. All right, Part E. Part E is where we really get investigative. Now, Parts A, B, C, and D have all been what I'll say within the curriculum. Those are all questions that students might have seen in a textbook or on a chapter test or something like that. But Part E really stretches students and makes them think carefully about sampling distributions in a new way. It says, suppose that one of the two sampling methods will be selected and used every day for 1 year, that is 365 days. The sample mean of the 200 diameters will be recorded each day. So they'll take a sample, get an X bar, record it. Next day, they'll take a sample, get an X bar, and record it. And they'll do that over and over and over again until they have 365 X bars. And the question says, which of the two methods will result in less variability in the distribution of the 365 sample means? Explain. So I'm going to skip over the model solution for a second and show you this picture. Then we'll come back and look at the model solution. The top half of the picture describes what would happen with method 1. That's actually our answer from Part D. In Part D, we said the distribution would look approximately normal, centered at 6, with a standard deviation of 0.0078, or a little bit less than 0.01. So the top half of the picture is the sampling distribution of X bar using method 1. Now with method 2, the sampling distribution is going to look different. Remember, with method 2, the manager flips a coin at the beginning of each day. If it's heads, the manager goes to production line A and takes a sample of size 200, and then would get a mean somewhere around 5.9. And if the manager flips tails, the manager will go to production line B, take a sample of 200 tortillas from production line B, and get a sample mean somewhere around 6.10. So the sampling distribution that you see down here at the bottom half of the picture is what you'd get if you use method 2 over and over and over for 365 days. So Part E asks, which of those two sampling distributions is more variable? Well, you can see in method 1, on average, these dots are only about 0.0078 away from the mean. But in method 2, these dots are about 0.10 away from the mean, either below or above. So method 2 has much more variability Method 1 has much less. So that was a really tough concept for kids to get through to be able to communicate what was happening with Method 2. Okay, so now let's go back to Part E and look at the model solution. It says Method 1 would result in less variability in the sample means over the 365 days. With Method 2, roughly half of the sample means would be around 5.9, and the other half would be around 6.1. With Method 1, however, the sample means will all be very close to 6 inches. There's the picture again. So common errors, although most students did answer Method 1, few students were able to describe the sampling distribution of the 365 sample means for Method 2 as having roughly half the sample means around 5.9 inches and the other half of the sample means around 6.1 inches. In some cases, it wasn't clear that the student was describing more than one mean. In other words, we didn't see that there was piles of X-bars around 5.9 and a pile of X-bars around 6.1. In other cases, students didn't imply that the sample means will vary from the population means by correctly using phrases like the sample means will cluster around 5.9 or around 6.1. The student answers imply that the sample mean will always be 5.9 or always be 6.1. Okay? In short, the way we graded this question was you had to be able to draw this picture on the bottom of this slide based only on the words that the student wrote. And if the student's communication didn't give you this picture, then they did not get full credit for Part E. And as you can imagine, Part E was the lowest scoring part of these 6. So teaching tips. Give students practice thinking about sampling distributions in unfamiliar context. Right? In our sampling distribution chapter, we do lots of problems about X-bar. We do lots of problems about p-hat. But any statistic that can be calculated from a sample has a sampling distribution. So ask your students this. How would you estimate the standard deviation of the sampling distribution of a sample median for samples of size 5 from a population of 1,000 students? Right? There's no formula that we learn that describes the standard deviation of a sample median. But you can talk about how you might simulate samples of size 5, record the median for each sample, do this many, many times, and then calculate the standard deviation of the simulated distribution of sample medians. This gets kids thinking really about what sampling distributions are, how they're built, and how we can describe them. A second tip is to make sure students are aware that the purpose of question 6, the investigative task, is to assess their ability to integrate statistical ideas and apply them in a new context or a non-routine way. You want to prepare students by showing them examples of previous investigative tasks or asking similar questions on assessments. Now, I want to make a quick point to clarify this. This question, Part E, will never be asked again. So it's not that you're trying to teach the content that has shown up in previous question 6s. There have been questions that involve multiple regression, questions that involve one-sided confidence intervals, things that are beyond the scope of the AP exam. So your goal is not to teach them all those contexts or those concepts or to try and anticipate what new concept might be asked about on next year's exam. What you want them to practice is practice statistical thinking. And these questions, previous question 6s, are great examples of that. If you're eager to try this soon, I just gave a test over Chapter 3 to my students, which is the chapter on linear regression. And you could easily use the 2014 investigative task, which was about fuel consumption rate for cars. And you could do that right away, first semester. I gave it to them on their Chapter 3 test. You could do it as an in-class activity if you want. But it was really a nice way to illustrate what question 6 is all about. So here's Part F. A government inspector will visit the facility on June 22nd to observe the sampling and to determine if the factory is in compliance with the advertised mean diameter of 6 inches. The manager knows that, with both sampling methods, the sample mean is an unbiased estimator of the population mean. Okay? However, the manager is unsure which method is more likely to produce a sample mean that is close to 6 inches on the day of sampling. Based on your previous answers, which of the two sampling methods, method 1 or method 2, is more likely to produce a sample mean close to 6 inches? Explain. So method 1 is more likely to produce a daily sample mean close to 6 inches. Because the sample mean is an unbiased estimator for both methods, the manager should pick the method that would result in less variability in the sampling distribution of the sample mean. Based on the answer to Part E, method 1 results in less variability. So ideally, if a student answered Part E correctly, in Part F, all they needed to do was recognize that it's referring back to Part E, and then essentially explain that that's what they've discovered. It wasn't a giveaway, though, because one, question E was pretty difficult. And also, remember in Part C, there was another question about variability where the answer was method 2. So students had to correctly know that Part E was the question they should be referring to and not Part C. So some teaching tips and some common errors. Many students answered method 1, gave an adequate justification based on what could happen on a single day. However, some of these students didn't indicate that the sample mean will vary from the population mean by using phrases like the sample mean will be around 5.9 or around 6.1 when discussing method 2. They simply said, oh, with method 2, the mean will be 5.9 or will be 6.1, not recognizing sampling variability. So tip, make sure students are conscious of sampling variability and that estimates from samples are very rarely exactly correct. And then many students did not see the connection between Part F and Part E. And the tip here is to remind students that the parts are often connected on free response questions, especially on the investigative task. A very typical investigative task will start students in a comfortable territory with questions that they've seen before, and then take them on a journey where they discover something new or they do some interesting task. And oftentimes there's intermediate steps that are sometimes quite easy that are provided so that students can reach the destination that the test development committee wants them to reach. So recognize that lots of times the parts are connected, especially on question 6. All right, so that's the review of question 6.